This is the most insane stream ever. If you watch this stream, you will go insane challenge. If you don't go insane, you will win $1 million. This is Minecraft. So let's play Minecraft. We should be streaming live right now. This is the most extreme, insane stream ever. Ever. I say ever. Jesus Christ. I may not be able to play. Because my April Fool's snapshot won't be on Heavy Feather client. Soy milk is kind of weird. Huh? Working. Okay. For the rest of the chest. Oh wow, that's just great. Really? Really? Okay, I'm gonna just attack the guy on my left. Oh. God damn it, man! I might just switch to Skyblock, man. God damn. Ooh, it's really good. Netherite. Oh my god. Oh, upgrade template. Alright, we can get a netherite pants. Oh my god. Do I even need this stuff? I don't need any of this shit. Oh. We gon' see how we do here, mate. Play some Skyblock. Alright, this is what I'm talking about, bro. Quest. Part 1. Welcome to Skyblock. This is your first quest. Completing the quest or a series of quests yields useful rewards. Start by gathering 10 oak logs. Alright, this is what I'm talking about, man. This is the stuff I'm talking about. Let's collect some logs, boy. It's kind of laggy, though. Can't lie. Just gonna collect logs like this, or am I gonna craft some tools? I'll craft the tools. Is there going to be any stone underground? Yes. We're not gonna get that yet. Log. Craft the crafting table. I have to manually craft another one. Harvest some beetroot and make some beetroot soup. Craft beetroot soup. Beetroot soup. Loot. 4 seconds and we should be good. Now what do we got next? Reward. Water bucket. Let's go. 3 cobblestone generators. Craft a full set of wooden tools. And then what else? Wooden shovel. Alright. 3 cobblestone generators. Let's go. Oh my god, it takes time. Fully generated. Gather oak logs. Generator. Mine cobblestone. Craft a furnace. Harvest some more of these. Maybe like expand the farm. Now I wonder if I place these down and then harvest them again, they don't work. Craft a furnace. Let there be light. Smelt logs into charcoal. 5 logs. 1, 2, 3, 4, 5. Turn cobblestone lumberjack. Should make some stone tools now. Oh my god, everything is fully grown. Oh, I want to eat one of these soon. Craft torches. Now I just gotta gather more logs. 1 minute of waiting time. Get a bunch of skyblock coins. Let's go. Oh, ran out of seeds? Oh shit. Okay, I still keep my stuff. That's good to know. Let's craft some stone tools. Alright. Fully stacked. Got some saplings from that. Upgrade. Craft stone tools, alright. I got that covered. Let's just do this. This. And it should be a shovel. A new island appears in the distance. Travel to the Plains Island. 1,000 coins. Harvest beetroot. Gather oak logs. Alright. Let's harvest some more beetroot. Plant some oak. Let's travel by planks. Okay. Potatoes, pumpkin. So many quests. Potatoes and pumpkins. Alright, I'm never gonna play this again. Can't lie. The most insane stream ever. 0 views. Alright, let's get to studying. Multi-dentated ligands.
Then we have more very complex. So we call it multi-dentated ligand. You can see from here. Okay, EDTA ligand is very famous in the laboratory. So doing some biotechnology in order to capture the DNA structure. Or we also can have this kind of EDTA complex. Okay, and then they were giving 6 data points back to the central micros. So one compound is very useful already. Okay, and then also we're cutting different type we call of the hydro complex, and then they all have 6 data points on board. And then here will be the type of 6 data point bond to the middle central metals. Okay, here with all the example, they just helping us to classify them. Okay, and then we have got the tetrahedral complex, and then cisplatin or pectins. They are using the scoring finger. Okay, so still remember the cisplatin. Okay, so all is 90 dB. Okay, so cis meaning that 4 of them appear on one side, so meaning cis. Okay, for the trans one will be opposite side. Okay, there will be difference in their morphology. Okay, and then also here show you some more example. We have also with the one which is happening more in the biomolecule and even in our DNA. Okay. Okay, can you see the screen?
Yeah.
Okay, and then the final is about the adverse effect. Okay, adverse effect, they will having some problem. Cisplatin bind to the healthy cell will having as a cancerous cell because they will affecting other cell to replicate very fast. Okay, so that will be one of the side effects. Okay, and also we have hair loss during cancer treatment because they will affecting the normal cell and then making our hair to be loose. Okay, and show you one more example, which is the hemoglobin. Okay, if we need to ask you for the hemoglobin, this is how many data points brought to the central ion from this diagram. At least 4, right?
Yeah, 4.
Yeah, but in the example they show us there's one more, but it's not seeing. It's 50 data from the protein moving to the FE. So normally for the hemoglobin complex, they will make up of 4 different hemoglobin, and then the majority they will have in the central structure. So actually meaning that beside the hemoglobin molecule, there's just one more data will be different by the protein. Okay, so they will be different. So here is 4 is related to the hemoglobin. This is the hemoglobin, and then we have one more protein which is also will giving one more cytoatom. So that would be the structure of having the hemoglobin, and then this is very useful in order to bind the oxygen to the red cell because we got in the heme group as well. And then it's just some interesting information about the ligand exchange in hemoglobin because we can have the oxygen binding to the hemoglobin. Okay, and that is also showing you one thing because hemoglobin can be replaced by carbon monoxide, which is not red colors, but it's kind of binding is reversible. So that's why the people will not having enough oxygen. And later we will die because of having a problem with the hemoglobin. And here showing you some property of catalysts for using as transition metal. For example, Fe will be using in the Haber process in order to produce ammonia. Okay, and then that will be the catalyst later. Okay, heterogeneous. Okay, so we talk about this later. Okay, and then we have some short recap for the transition metals. Okay. And then last time because we studied about chromium. The chromium is very big, one of the very famous.
Reduced by zinc to form chromium 3 plus. So Cr2O is 72 minus. So that's plus 6 for chromium. Plus 3 zinc becomes Cr2 Cr3 plus 3 Zn2 plus 7H2O. And then we get Cr3 plus 2 Cr3 plus Zn becomes 2 Cr2 plus Zn2 plus. And the Cr2 plus combines with 4 ethanoate to form chromium ethanoate. Chromium 2 ethanoate with 2 water molecules.
This transition metal, which is many different chemical reactions. So we go back to the 176 about the reaction of the ligand. Okay, we show you the ligand where we have very much different ligand. Just say
ligands can exchange places with one another. One ligand can be swapped for another ligand. This is ligand exchange. It usually causes a color change. If the ligands are similar size, H2O, NH3, Cn- or OH-, then the coordination number of the complex ion doesn't change and neither does the shape. Okay, octahedral dark green plus 6 NH3 becomes octahedral purple, so still octahedral. If a small uncharged ligand is substituted for a large charged ligand, or vice versa, there is a change of coordination number and change of shape. So we got octahedral plus Cl-, so then it becomes tetrahedral. Octahedral, cobalt, aqueous cobalt complex, tetrahedral, octahedral to tetrahedral. The charge changes as well.
Ammonia, chloride, all which can provide the coordinated bond. They are also the ligand. But remember, they will be tested already. When ligand exchange, that will causing a color changes. Okay, because the ions being different at the same time, sometimes the shape will be different, and then they will changing the colors. Okay, so normally the size and coordinate number will not be changed, but the colors will be changed. Okay, for example, we can see the first formula. We just exchange the H2O to ammonia, right?
Yeah.
So actually, the number will be equivalent to the ligand I want to do in this space. Okay, so the color change will be very easy. Just remember when this is purple. Okay, at the same time, need to remember because because some of the ligands do not have charge, just like H2O, because they don't have any charge. Ammonia, they don't have any charge. So there will not be any oxidation number changes in the formula, okay? So we take a look for the second example. If we change from the H2O, okay, the octahedral ligand, the complex ion, change with the tetrahedral one, change with the other, because with chloride.
Sometimes the substitution is only partial. 6H2O plus 4NH3. Yeah, that seems partial to me.
So there will be a changing in the coordinate number and also with the change with the shape. Okay, so here we have octahedral pale blue purpose and then change to the tetrahedral yellow. And for the right hand side, we have octahedral pale pink, change to the tetrahedral blue. Okay, and then sometimes it's more special. We cannot do it the complete substitution. We can only do half or only doing a partial. So here we show us about an example. The octahedral one become pale blue to the dark blue. We can see the example before, and then we can do it like this. Okay, but there is one thing.
Since it's in solution and contains ligands that aren't water, you need to include all the water ligands when writing formula of a complex like CuNH3 4H2O2. But if you're writing out the formula of a precipitate such as CuH2O4OH2, you can leave out the water ligands and just write CuOH2. As it's in solution and contains ligands that aren't water, you need to include all the water ligands when writing a formula of complex. But if you're writing out a formula of a precipitate, okay, so not in solution. So when it is aqueous, you have to include all the water ligands. If it is a precipitate and solid, then you don't have to.
For writing this formula, which one should be writing first? But you can write the formula on precipitate just as Cooper's word. We can leave out the water ligand and just write CO2. In that sometimes, if we just need to write the precipitates, we can leave out the H2O, okay? But here is for writing the complex. So make sure that we knowing about the difference because some hydrogen ion, we cannot be writing like this, okay? At the same time, the reaction, you'll be adding a bit, when except for ammonia, we do it before. Just add a bit, they will move in a blue precipitate, okay? So we can see the reaction will be different, okay? So remember the color change and knowing about the ligand. And the second one, we just tell you in the other notes about the hemoglobin. The hemoglobin can be exchanged to the carboxyhemoglobin. This is very big news for carbon monoxide, forming a stronger covalent bond with iron. This doesn't.
Oxygen or water molecule in hemoglobin can be replaced in a ligand exchange reaction by carbon monoxide, forming carboxyhemoglobin. This is bad news because carbon monoxide forms strong oxidative covalent bond with the iron ion and doesn't readily exchange with oxygen or water ligands, meaning hemoglobin cannot transport oxygen anymore. This leads to carbon monoxide poisoning.
Readily exchange. So this is a irreversible poisoning to the hemoglobin. Okay, and then they can't carry transport oxygen more, so that will become carbon monoxide poisoning. This is also about the ligand exchange. Okay, so this is our irreversible exchange. Okay, and then we click to look.
We click a look. When a ligand exchange reaction occurs, dative bonds are broken and formed. The strength of the bonds being broken is often very similar to the strength of the new bonds being made. So the enthalpy change for a ligand exchange reaction is usually very small. For example, the reaction substituting ammonia with ethane 1,2-diamine in a nickel complex has a very small enthalpy change of reaction. And a nickel complex has a very small enthalpy change of reaction. Okay, but that's exchanging 6 with 3. This is actually a reversible reaction. It's a very small enthalpy change of reaction. This is actually a reversible reaction, but the equilibrium lies so far to the right that it is thought of as being irreversible. This is much more stable than this. This isn't accounted for by enthalpy change. Instead, it's to do with the entropy change of the reaction. When monodentate ligands are substituted with bidentate or multidentate ligands, the number of particles in the solution increases. The more particles, the greater the entropy, and so the reaction that results in an increase in the entropy are more likely to occur. Okay. That makes sense. So for substitutions, it is thermodynamically more feasible to substitute monodentate with multidentate ligands so that the entropy increases and the reaction becomes more feasible. When the hexadentate ligand EDTA4- replaces monodentate or bidentate ligands, the complex is formed a lot more stable. A lot more thermodynamically feasible. A lot more stable. So many colors. What color is she? New role. The cat person. And I'm the Super Saiyan.
For the three different information about the ligand exchange. Okay. First of all, for the nickel, we have NH3. They can happen 6 covalent bond. Okay. So we use ammonia to donate 1 beta covalent bond. But we got the other molecule. Okay. For this molecule, each molecule can happen to giving how many data covalent bond to the central nickel ion? This one.
Yep.
2. Okay. So 3 times 2, each one giving still 6. Okay. And they're giving out the reaction, which is a isothermic reaction. Okay. So meaning here, we're talking about the enthalpy change. The energy changes for a reaction is usually very small. So this is not big. Okay. Because the strength of the bond breaking is very similar to the bond breaking. So we learned it before. If the bond breaking, we require energy or we not require energy for breaking bonds. I do cut the bond and
When
reform
we're
the bond.
breaking bonds. When we're breaking bonds, we are putting energy into the system.
Which one require energy? Which one will give out energy? Normally we use
Forming the bond.
Yes, forming the bond will giving out the energy, right? So that's why we can calculate which one is more stable at the same time. So for looking at number 2, this is a actually reversible reaction. The equilibrium is so nigh to the right, it is being irreversible. Meaning that we need to know which one is getting more stable. Is the one being more stable, the reaction will be more closely going to be there. Okay, so accounting for enthalpy change and also with the enthalpy and also with the entropy, we need to also see which one will be more stable in order to see which reaction will be more favorable. Okay, so for the example here, so monodentate ligand substitute with the bidentate or multidentate ligand, the number of particles in the solution will be increased. Okay, the more particle, the greater the entropy. So the reaction that result in the greater entropy is more likely to occur. They would like to have more molecule. Okay, so that's why that will be having the entropy will be getting more likely to be occur. Okay, so entropy can happen also as to determine whether the ligand exchange will be happen. Okay, so we can see from the third one here. For example, here is the ammonia further by EDTA. So in total, as before, there's only 2 molecules. Now you change into the 6 ammonia and 1 is EDTA compound. We got in 6 second molecule, and we know that this entropy will be positive. Or we know before. If the entropy is positive, the delta.
Why are these guys ignoring me, man?
Delta T equal to delta H minus delta this value, the reaction is feasible. So we can check it for contact. So this one is from 2 to 7. How about this reaction? From how many molecule to how many more?
4 to 7.
Yes, so it's more feasible at the same time. So we can take a look for this. Okay. So the reaction of ligand we already know about just like transfer of the ligand, and then we're using the some small ligand with a complex complex ligand as well. And then one more reaction that will happen is the transition element hydroxide will also seeing the bright colors precipitate. Okay, so we have a table about
Transition
the
element hydroxides are brightly colored precipitates. When you mix an aqueous solution of transition metal ions with aqueous sodium hydroxide or aqueous ammonia, the water ligands are deprotonated in an acid-base reaction and you get a colored hydroxide precipitate. When you reverse these reactions by adding acid to the hydroxide precipitate, the hydroxide ligands will protonate and the precipitate will dissolve as the soluble metal aqua ions are reformed, so aqueous complexes. In aqueous solutions, transition metals take the form of metal H2O6 N+, as they can also be written as Mn+. As long as the metal ion is only bonded to water. Okay. If it's bonded to anything else, you need to write out the whole formula. You need to know the equations for the following reactions and the colors of the hydroxide precipitates. And the colors as well. Copper is blue. Copper reacting with hydroxide deprotonates two water molecules to form OH2. So that goes from a pale blue to a blue precipitate. So pale blue solution to blue precipitate. This can also be written as Cu2 plus 2H minus to CuOH2. CuH2O6 2 plus NH3 deprotonates two H2O molecules becomes OH2. In excess ammonia, copper hydroxide undergoes a ligand exchange reaction. Excess ammonia, so 4 NH3, deep blue in solution. Huh. COH2H2O 4 plus 4NH3, and it replaces 2H2O and 2OH2. I mean 2OH. But I thought it was 6. NH3 replaced all 6 molecules. But I guess it replaces... Why is there 4 H2Os? Two OH minus 2H2O. What? How is copper becoming cobalt? This is weird. How come there's 4H2? That's just weird, man. So what is a sona?
precipitate forming before. Normally, we will mix the aqueous solution of hydrogen and iron with sodium hydroxide and also aqueous ammonia. Some of the bottleneck deprotonate in acidic state. Okay, at the same time they will forming a colorless hydroxide precipitate. Okay, some of them are partly, some of them are completely. So at the same time, we can see the color changes happens in order to seeing the negative string reaction. Okay, so we show some example. So for the second principle, you'll be using the acid to do the hydroxide precipitate continue. Okay, the hydroxide negative will protonate, and the material will finally dissolve at a soluble metal aqueous ion will form. And the next step, the aqueous solution hydroxide can forming a hydrated metal ion, and also can be weighted as M as long as the metal ion is only bound to the waters, which I can write out the whole formula. So we can see in the example below, okay, from the different ion. So first of all, we got in the copper. A bit complex now, we can see one by one now, okay. First of all, copper. At the beginning, we have waters, and then we get into the hydroxide ion. They will burn partially extract, okay. But because we cutting the water content here already, okay. So this formula we can shorten like writing like this, okay. Remember we see this before, right? And when we're doing with the precipitate, then we're having this, okay. This because this one is insoluble, so meaning that we can negate the water's present when we write this. The other is the one we're using the ammonia, okay. The ammonia they also for precipitate, at the same time they also remaining below, okay. So in excess copper.
So with iron, same logic. Same logic. Iron 3 plus. Alright, I might want to write these down.
Be here today though.
Hey, Chris.
Hey Chris.
Hello.
Hello.
Hello everybody.
How are
Wait,
you?
do I need
Fine,
to
thank you.
do I need to send my thing as well? Hold up, I should do that way.
You are going to send your VTuber model?
I didn't
Why do you sound like
not
that?
not enough time to actually finish it, so I'm
That's
gonna
fine.
yeah. Where did my Apple Pen go?
Your apple
Pineapple
pen? Pineapple apple pen?
Pen pineapple
Yes.
apple pen.
Yes, my pen apple. Wait, what? Pen
Your pen apple.
pen.
Your pen
Wait,
apple?
what do you say? Pen.
Your pen apple.
Wait, what? Hold up.
Pen apple.
Apple pen. What?
Apple pen.
Oh, Apple Pen. Oh, I'm confused. Wait, where's my pen? I put it right here
I took
a
it.
second ago. It's gone. Oh my god, I found it. It's just behind my iPad.
Kirog, I might not be able to play the April Fool's update because I don't have access to my account on the Minecraft
Oh,
launcher.
What happened?
Quickly, just ask.
He's not gonna like reply. He's offline on Discord. If I ask him on Instagram, he's just gonna reply to me like tomorrow morning or something.
Yeah, I get that.
Spam call him.
He's gonna block me or something.
He's not that kind of person.
Okay, I'll ask him on Instagram.
He's not that kind of person. He wouldn't do that.
Hmm. Can I play vanilla or mod prince? I wonder. Library. Let me add a new one. Custom setup. Game version. Wait, no. No, I'm just gonna have to go to the Minecraft April Fools 2026 version.
Okay, time to. Let me finish making let me finish my model, and then I'm gonna quickly make. I didn't even make the server yet.
Oh
I
my
could do it
god.
really quickly. Yes.
I'm
don't
checking
worry.
if we can actually play this because I'm kind of scared now because I don't see it on Modbrain, but I don't see it on Lunar Client. I'm gonna have to go to the actual. Why is there a little sheep? There's a little dog. There's a little pig. What's going on? There's a
The-
The
chicken.
baby
The Minecraft
update.
loading screen? Yeah.
What?
The baby update.
What is happening? Why are there so many of them? Oh my god. Oh my god. They're all following me. Help. 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 What is happening? Am I free?
I don't know what is happening, or why it's happening, or where it's happening. It's from Kinger.
Yeah.
Hold on. Patch notes installations. Let's new installation. It's the latest snapshot. Is it that one? Yes, it is. Okay, so it's still here. It's April Fools 2026. Install. Oh, they're so cute. Oh, and here they are again.
I'll
Can I
get.
just
I'll
beat
draw
them?
the banner
Can I
right
beat-
now.
Yippee!
Hold up.
Did you
What's
get
I
the
need to
what's the
send.
size?
You're gonna have to Google that. I usually use a
Yeah.
template. Give me a sec. Do you want Twitch or YouTube? I think it's almost the same. I'm gonna give you the
It's
YouTube
almost the
size.
same. Yeah. Give me YouTube.
YouTube banner size. I usually just Google it. Let me see, which one is it? I think
Yeah, I usually
use-
Google it too.
I think I use this one. Let me send it to. Actually, no, that's Pinterest. I don't trust Pinterest. I'm gonna put it in the VC chat. Yep, I'm in Herbcraft. I'm so sorry for not replying you.
Oh, I always use this template.
Yeah, same. It's either this one or the blue one. Hermitcraft? No, Hurtcraft.
Oh, I used the blue one.